Alright, hello and welcome to Maths with El Profilo, working on some Unit 2B notes and some word problems. Alright, so here is a situation of the type of real world piece that does occur, alright, and that we need to be able to think about and analyze. Okay, so we have a shipping company and they need to design a closed box with a square base that has volume of 1,000 cubic inches. Right? We want to determine the dimensions that minimize the amount of cardboard used to construct the box. Right? So not much information initially, so we have to think through. Right? So we're going to have a closed box with a square base. So if we can get a design, right, kind of imagine what our box looks like. So there we have a box, right, and let's have a square base, and let's say that we have some height to this box, right? We know that the volume is length times width times height, which will be x squared times the height, and we know that that needs to be 10,000. Right? Well, what does that tell me? That tells me that h has to be 10,000 divided by x squared. Okay, so we have basic information. Now, we need to determine the dimensions that minimize the amount of cardboard used to construct the box. So we have to think, right, what measure do we need if we're talking about how much cardboard that we use, right? And that measure is going to be talking about the surface area, right? That we need to discuss, hey, how much surface area is this box going to take up, right? So here we have this box. How much surface area is it going to take up? So I need an equation for my surface area. And that surface area, I know I have the base of x squared, the top of x squared, right? And then I have the four sides, and the four sides each have, right, x times h, right? So really I could say that that surface area is 2x squared plus 4xh. Okay? And we want to minimize this particular function. So we need to graph this, right? So we're going to go ahead and graph y equals 2x squared plus 4x times 10,000 over x squared, right? That's my function, because I substituted for h. So let's go ahead and get our calculator and put this in and see what we get. So let's clear our piece, clear what we had before, and we've got 2x squared plus 4x times, right, 10,000 all over x squared. All right, and close my parentheses. Notice that I'm not trying to simplify anything. I'm just putting in the information as I see it. So I'll go ahead, press enter, and then once again zoom, right? Zoom fit, which is option 0, right, is a nice place to start if you're going to be using these really big numbers. And the graph tends to come in, right? And so now we can see our graph. And we see overall what seems to be occurring. We see that we do have some sort of minimum. So I'll come back over here to my window, right? I can see my x max is 100, my x scale is going by tens, right? But my y minimum doesn't need to be so big. My y maximum, right? Maybe we just once again put it down to 5,000, right? And just have a gander now at what our graph looks like. All right, so there we can see the basic shape of our graph, right? It seems to come down and go back up. Okay, so I'm going to go ahead and draw my graph, right? That my graph seems to be setting up in this form. I seem to have a minimum value, so let's go ahead. Second, calculate that minimum value, right? And I can arrow over to the left of the minimum, press enter, arrow to the right of the minimum, press enter a third time, and there it gives me my minimum value, which says an x value of about 21.5, and a y value of, let's see, 2784.9, so about 2785. All right, so there I have my piece. All right, so we're looking for the minimum, and this is surface area as a function of x. Right. So over here we were looking for the dimensions that minimize the amount of cardboard used to construct the box. Right. So therefore, dimensions are x equals 21.5 inches, and h would be, well, h is going to be what? 10,000. There's 10,000 divided by x squared, right? That's our formula for h. So we look at that, and this seems to be about 21.6 inches, right? And so we might have some rounding issues there, but let's just double check. 21.5 times 21.6, right? Then times 21.5 again, and that gives me a volume that is very, very close to the 10,000 that I was looking for. So we probably did have some rounding, right, that occurred, right? And we can see that it seems like we do have a very close to cubic box that is going to minimize the amount of cardboard that I use, right? So why might I want to minimize the amount of cardboard used? Well, probably because of costs, right? That if it costs to make these boxes, right, then this will give me possibly a minimum cost. Right? So there we have a problem that involves some rational functions and some mixed functions. Right? Didn't have very much information given to us initially, but we can work through the information to get to a solution. So this has been Maths with El Profelo. Very much thank you for your time. As always, ask questions for clarification when needed.